Díomh agus fáilte roimh. We hope you're keeping well. We hope you're staying safe. We hope you're washing your hands and not touching your face. I kind of like that. Boys and girls, today we're going to be doing some science. And in particular, we're going to be focusing on electricity. Let's think of that word electricity. Do we use electricity a lot? I've got a great idea. Why don't you look around the room you're in now and see what kind of things use electricity? I'll do the same here. Well, straight away, I'm looking at a camera, so that uses electricity. I can see there's lights making me look pretty. They're not doing a great job. Over here, we have an interactive whiteboard plugged in. So, yeah, there's a lot of electricity in the room. In fact, you don't even have to look too far. It's right in my watch. Nowadays, all of your items are probably electrical. When you get up in the morning, you might make yourself some toast, which is using electricity. You might boil an egg, which is probably using electricity. In fact, nowadays, even cars are completely electrical. Electricity is everywhere. But what exactly is it? Well, electricity is an energy. And we find it from wind. Maybe you've driven past a big windmill. They're actually wind turbines. So the wind is creating electricity and energy. We can get electricity from the sun using solar panels. We can get electricity from water. And we can even make electricity from animal poo. But don't worry, that's not what we're going to be doing today. There are two types of electricity. There's current electricity, which means the electricity is constantly moving. And there's static electricity, which means it stays in the same place. I'm going to give you a small example of static electricity right now. Balloons! And no, it's not my birthday. I wish. This is to show you an example of static electricity. So as I said, electricity is an energy. So if we rub a balloon off our hair like this, we're actually creating energy. Now, I know my hair is going to be a little bit messed up after this, but don't worry about it. I got a brush. I'm going to give it a good rub. Maybe someone at home will let you do this to them. And now, we should have a lot of static electricity right here where I was rubbing the balloon. Let's see. So if I stick this balloon to the wall, it should stay up. Yes! Now, as I said, static electricity stays in the same spot. So if I take my balloon, turn it around to where I wasn't rubbing, and try and stick it to the wall, it doesn't stick. That's static electricity. The other type of electricity is current electricity, which means the electricity is flowing constantly. So with current electricity, there are insulators and conductors. An electrical conductor means that electricity will pass through an object, completing the circuit. An electrical insulator means it will not allow electricity to pass through it. So, as you can see, I have a lot of stuff on my desk. What we're going to do today is we're going to see which items are electrical conductors and which items are electrical insulators. In other words, the items that let electricity pass through them are conductors, and the items that stop the electricity are electrical insulators. So what else do I have on my table? Well, I have a battery pack. This has 2 batteries in it, and there are 2 wires sticking out of it. See, we have a red one and a black one. One of them represents the positive outlet, and one of them represents the negative outlet. I've got some wires here with little crocodile clips at either end. These are really, really handy. And you can see, oh, he's just got these tiny, teeny little crocodile teeth. That'll help us because it means we can grip on and see which ones are conductors and which are insulators. As well as that, I have a bulb. Now, the reason I chose a bulb for our circuit is because if we have an electrical insulator, our bulb will not light up because electricity won't be passing through the circuit. If the bulb does light up, it means that whatever we're using is an electrical conductor. I've also got a ruler, excellent for making straight lines, but let's see if it's an insulator or a conductor. I have a coin, not worth a whole lot of money, but it could be a really, really good electrical conductor. I have a nail, a fairly big nail. I have some blue tack. Yeah, very stretchy. This is a good piece of blue tack. But I wonder, will it let an electrical current flow through it? I have some tin foil, which was left over from my lunch earlier. It was a sandwich, really tasty. I have a wooden shape that's painted green. If you watched my maths lesson, you should know what this shape is called. I have some toothpicks, also left over from after lunch earlier on. Ow. I have some string, just some normal run-of-the-mill string. I have a balloon, left over from the ones that I was blowing up earlier on. And I have a scissors. Be very careful with these. So, let's set up our circuit. When we've finished with the items, we can leave them over here under the insulator pile or under the conductor pile. Now, just to give you an example of a fully functioning circuit, I'm going to take my wires, I'm going to connect them to my battery pack, I'm going to connect the other end to my bulb, and we're going to put this wire connecting it right back to the other end of the battery pack. Now, when I connect these two wires, this light bulb should light up. Here we go. Hey, it works! Look at that. Okay, now we have a fully functioning circuit. Let's add some more things into our circuit to find out which ones are conductors and which ones are insulators. So I'm going to put the bulb down, I'm going to take off this wire, and we are going to add some more things into our circuit. Okay, green wire goes on here. Now, instead of connecting this green wire and this black wire, I'm going to add in some more things to our circuit to find out if they are conductors or if they're insulators. What should we start with? You know, I enjoyed the balloon earlier on, so let's start with that. Okay, so I'm connecting the balloon to the wire. And if this is a good conductor, it means that our bulb should light up. Oh, nope. Okay. So this balloon is going over here to our insulator pile. So which one will we try next? How about the nail? Okay, I'm going to connect the green wire. And if I attach the black wire and the bulb lights up, it means it's a conductor. Let's have a little prediction. What do you think is going to happen? Do you think it's going to light the bulb up and therefore going in the conductor pile? Or do you think it's going to stop the electricity flow and therefore it's an insulator? 3, 2, 1. Hey, look at that! That's lighting brightly. Okay, so that means our nail is a conductor. What next? What next? What next? Let's try this string. The reason I want to try this is because it kind of looks like a wire as it is. Here we go. Green crocodile clip on. What do you think is going to happen? And okay, so this is an electrical insulator. It does not allow the electricity to pass through it. So it goes over here in our insulator pile. Next. Let's try our coin. This is teeny tiny. I'm not sure if it's big enough to let electricity pass through it. Let's find out. Green wire attached. Come on, light bulb. Hey, it works! Wow. Okay, so our coin is also a conductor. What next? What next? What next? Let's try our wooden ruler. I really like this ruler. Drum roll, please. Ah. Well, I say but to be honest, insulators are actually really useful as well. Can you think of any reasons why an insulator would be useful? Have you ever seen animals behind an electric fence? Now, the reason the fence is electric is because if the animal walks into it, it'll give them a little shock and they'll know not to walk there again. But if a human touches their hand off an electric fence, it can be really, really dangerous. So that's why it's good to have insulators that you can wrap around the wires to make sure you don't get a shock. Electricity can be dangerous, so if you're planning on doing any of this stuff, please make sure that there's an adult with you. Okay, what's up next? Let's try our toothpick. Now, earlier on, we had a wooden ruler. So I'm not so sure if this is going to work. What do you think? Thought so. A wooden ruler and a wooden toothpick are very similar, so therefore it is not a good conductor. And it goes over here in our insulator pile. Let's try the tin foil next. Green wire attached. Black wire. Predictions, please. Predictions, please. Is it going to be a yes or a no? It's a yes. The bulb is lighting. Okay, so that means that tin foil is going here in our conductor pile. Now, I'm going to move all these aside and I'm going to show you how to draw a circuit. So when you get a little bit older, you might have to draw circuits in secondary school. And when you get older still, you might have a job drawing circuits, like an electrician or a mechanic or an engineer. So I'm going to teach you how to draw a circuit right now. For this, you're going to need paper, a ruler, and a marker. Now, when you grow up, if you're in a job where you have to draw circuits all the time, you won't have time to draw a teeny tiny little bulb and the intricacies of a battery because there's loads of little bits. So what they do is they use symbols. I'm going to show you some of these symbols now. Wow, that looks really easy to draw. That's the symbol of a bulb. It's just a circle with an X going through it. Let's have a look at our next symbol. This is the battery. I know because I can see the positive symbol and the negative symbol. That's a little trickier to draw, but it's still quite simple. And last but not least, we have, the wire is just a line. Well, that's pretty straightforward. Okay, here we go. I'm going to draw the circuit that we just made with the bulb. So we have our wire, we have our battery, now I'm using the ruler just to make sure my wires are straight. Don't want to get any cross wires. The wire went on, it went down here, it went over, and then we had our bulb. Then the wire went on, and it went all the way up, but I'm going to leave a gap. And the reason I'm going to leave a gap is because we included various items in our circuit. So we had tinfoil, a coin, a nail, a wooden ruler, a toothpick, some string, and a balloon. When you're drawing out your own circuit, you can just draw them in there and then put a tick beside it to tell us if the circuit was going to work or if it wasn't going to work. In other words, if this item was a conductor or an insulator. What did we learn in today's science lesson? We learned that there are two forms of electricity, static electricity and current electricity. We learned that electricity is an energy. We learned where electricity can be found and how it is made. We learned that within current electricity, there are insulators and there are conductors. A conductor means that electricity will pass through it. An insulator means that the electricity will be stopped. We also learned how to draw a circuit.